Hello, everyone. This is Dr. Lennon, and today we're going to talk about the rectangular coordinates or the Cartesian coordinate plane. So, uh, let's go ahead and jump right in. Uh, so, uh, any point x comma y may be plotted in the two-dimensional plane known as the xy plane or the Cartesian coordinate plane after its inventor, the French mathematician and philosopher René Descartes. So I have one Descartes joke. I don't know if you've ever heard it, but René Descartes was also famous for saying, "I think, therefore I am, cogito ergo sum." So, the joke goes like this. René Descartes walks into a bar and the bartender asks him if he'll have a beer, and he says, "I think not," and vanishes. Ha ha ha. Right. I think, therefore I am. So if he thinks not, he's gone. Anyway, so here's how it works, right? Basically, the x-axis is the horizontal axis. So the x-axis is the horizontal axis and the y-axis is the vertical axis. The horizontal axis maybe I should use a colon. A colon's better than a hyphen here, right? Hyphens in math, you start thinking subtraction. And then we have two directions, right? So we have the basically for the horizontal axis, right is positive and left is negative. And for the vertical axis, up is positive and down is negative. So those are our orientations for positive and negative values. And then also points are graphed according to the XY convention. So the X coordinate comes first and the Y coordinate comes second. So doing that, we can divide the plane into 4 quadrants. So they are labeled counterclockwise in this direction. So 1, 2, 3 is the bottom left, and 4 is the bottom right. So you can think about what should be the signs of your pairs in each quadrant. So the x coordinate is positive and the y coordinate is positive in quadrant 1. In quadrant 2, your x coordinate is negative, but your y coordinate is positive. In quadrant 3, they are both negative, and in quadrant 4, your x is positive and your y is negative. So we could ask some pretty basic questions here. We could say, example, in which quadrant is the point -1, 5? So it has a negative x coordinate and a positive y coordinate. So we know it is in quadrant 2. So the answer here is quadrant 2. And we could go ahead and plot it as well. So basically, you would make a tick mark 1 to the left, and then you would go up 5. So think of it as a two-step set of directions. I start at the middle, I go 1 to the left, then I go up 5. So this is my point, -1, 5. That's how I would graph that. And then from there, we can relate are points to some of the linear equations we were looking at last time. So let's look at an example of that. So we could say, does 3, negative 4 satisfy 4x plus y equals 8? So what you have to do is you have to plug in the first coordinate for x and the second coordinate for y, and you see if you get something true. So we get 4, plug in 3 for x, and then plug in minus 4 for y, and we're asking, does this equal 8? So if the left-hand side comes out to 8, we're all set. So does 12 minus 4 equal 8? It sure does. So the answer is yes, this is a solution to the linear equation. So yes, we would say 3, negative 4 is a solution. We can also look at what this looks like graphically. So we're not going to talk about graphing linear equations today, but that will come up shortly. So a website I like to use for graphing calculator is dsmos.com. So it will direct you to this page. Then you can click graphing calculator, and we can graph all those things. So the thing we were looking at, 4x plus y equals 8, we see that that is in fact a line, and we'll learn how to graph those in the near future. But I think we can also plot points on here too. So we can, I think, just put negative 1, 5, and oh, we were graphing 3, negative 4. That was the previous point we plotted. Negative 3, 4. 3, negative 4. I'm a mess with my negative signs today. 3, negative 4, and we see that dot, and we see it falls on the line. So if you plot any point and it falls on that line, that would mean it's a solution. It satisfies that equation. So let's do one more of this type. Let's say example, does negative 6, negative 9 satisfy x equals minus 6? Well, this is actually quite easy. The y coordinate doesn't even matter. That's all we actually need to plug in is negative 6. So if you plug in negative 6 for x, does that equal negative 6? Sure does. Yes. Negative 6, negative 9 is a solution. So if you have only x equals a number or y equals a number, and you tried to think about what that would look like in the plane, that would be all the points that satisfy x equals negative 6. So that's every point with an x coordinate of negative 6. So that actually just comes out to a vertical line. So we can check that again here. If I just say, what does x equal negative 6 look like? It looks like that. And then I could, again, plot that point negative 6, negative 9. And my window's a touch too small, but if I scroll down a bit, I see that dot down here, and it does in fact fall right on that line. So let's go ahead and talk about plugging in points, and that'll basically be it for today. So if you have an equation and you have either an x or y value, you can plug that in and figure out what the other point should be. So let's say let y equal 2x minus 1 if x equals 4, what is y? So we go ahead and just plug in that value. So we say y is equal to, we replace x with that number 4, and we can figure out what the coordinate is. So we have 8 minus 1, which is 7. So basically, this tells us that the point 4, 7 is on the line y equals 2x minus 1. Again, we'll go back to the graph just to confirm that. So we can say y equals 2x minus 1. And let me scroll back up so we're in a reasonable window. And we said, okay, well, 4, 7 should be on that line. And we see it right up there. They could also give us a y value and ask what is the x value. What would that look like? So example, let's say let y equal minus 3x plus 2 if y equals 17. What is x? So basically we go to the equation and we change y to 17 and then we have to solve for x. So this turns into one of our linear equations from last time. It's just a two-step equation where we want to subtract 2 and then divide by -3. So we have 15 equals minus 3x, divide by -3, and we have -5 is equal to x. So this tells me that -5, remember the x comes first, 17, is on the line y equals minus 3x plus 2. And you could graph that. I'm not going to graph this one, but you can always go to Desmos and double check that. It's a very handy tool to graph things and much more accurate than doing it by hand. We can also do multiple values. So a lot of times you'll see tables of values with functions. So let's say complete the table given 7x plus 2y equals 84. And let's say the table looks like this. We have an x and a y. And okay, so we want to figure out y when x is 0. We want to figure out x when y is 0. And we want to figure out y when x is 2. So basically, that's like a part A, part B, and part C. So let's say part A, x equals 0. We can go ahead and plug that in. 7 times 0 plus 2 times y, that's 84. So the 7 times 0 goes away. We have 2y equals 84. Divide by 2, we get y equals 42. So 42. I think that was Jackie Robinson's number in baseball, if you're a baseball fan. B, let's say we want to do y equals 0. So we'd have 7x plus 2 times 0 equals 84. So now we have 7 times x equals 84. Divide by 7. We get x is equal to 12. So 12 would be the answer here. So that's part A, part B, and now part C, we want to do it when x equals 2. So we have 7 times 2 plus 2 times y equals 84. So we have 14 plus 2y equals 84. So we just subtract 14 and divide by 2. So we have 2y equals 70, divide by 2, and we end up with y equals 35. So that would be your answer to this third one. And that's really it for rectangular coordinates. Pretty basic, just plotting points. First coordinate x tells you whether to move right or left. Second coordinate y tells you whether to move up or down. To the right is positive and up is positive. To the left is negative, down is negative. And then when you're plugging in things, just remember, plug in the first number for x and the second number for y. And that's pretty much it. Probably, again, this is just a review for most people, but things are set up kind of as expected. Anyhow, this is Dr. Lennon signing off.